Okay, question 3. Cortisol is a hydrophobic signaling molecule produced by the human adrenal gland that affects a number of different tissues in responses to stress. It has a role in increasing blood sugar levels, in suppressing the immune system, and in promoting the metabolism of fats, proteins, and carbohydrates. Okay, cortisol is a steroid hormone. Describe the mechanism by which this type of signaling molecule causes an effect within the target cell. Okay, so because it's told you it's a steroid hormone, and more importantly, actually, I suppose up here, they're telling you it's hydrophobic. Okay, so even if they hadn't told you it was hydrophobic, the fact they told you it was steroid should have automatically said, well, that's hydrophobic. And what you know about hydrophobics is that they cross the cell membrane. Okay, so cortisol crosses the cell membrane, and that's your first stage. Okay, once it's in the cell, it binds to intracellular receptors, but just receptors. Now those receptors then impact on gene expression, which alter gene expression. The reason that they alter gene expression is because they are transcription factors. Okay, but even if you're just saying alters gene expression, you've got the mark. That's basically it. Okay, suggest a way in which cortisol might have different effects in different tissues. So, because what they've said here, it does lots of different things. Okay, so increasing blood sugars, suppressing immune system, promotion of metabolism, and different things. So they're going to be different cells that are doing that. So the easiest thing to do that is just to have different receptors. So if you have different receptors, we'll have a different gene expression, different pattern of gene expression. And I think that's really the best one to explain or to give. In the mark scheme, they also said that you could have different pathways within the cell, which is pretty much saying the same thing, and different genes can be switched on and off, which is exactly what they say here, or that you've got different receptors, which is what's there. So I think in that answer there, I've actually given you two of the marks within that. Okay, Addison's disease, a disorder. In fact, I'm going to move this over slightly. Sorry if that's a little bit blip in your head. Okay, Addison's disease is a disorder in which the adrenal glands do not provide sufficient cortisol. One test for this disease is to give the patient an injection of a hormone called ACTH, which stimulates the adrenal gland to release cortisol. In a healthy person, cortisol levels should rise by at least 70 micrograms per litre after 30 minutes and 110 micrograms per litre after 60. The graph shows the results of the test on 3 patients who were investigated for Addison's disease. Right, so we've got the serum cortisol, you've got the time in minutes along the bottom, and we're just looking for, do they hit these levels to be healthy? Patient 1 does not have Addison's, patient 3 has Addison's. State the diagnosis that would be appropriate for patient 2, using data to justify your answer. Patient 2 there. Right, can't remember if I think I must have clipped off some of the space for writing, because you must have more than that. Right, going from a wee highlighter here. Patient 2, I'm ignoring patient 1 and patient 3, I don't care about them anymore. They know what's going on. Okay, so patient 1 started at 50, and at 30 minutes, now these are going up in tens, but that's on the half box, and you're expected to be able to do that. So that's 125, and then at 60 minutes, we've got them up at 175. Okay, so there's my data points. Okay, so patient 2, okay, starts at 50 micrograms per litre. At 30 minutes is at, what did I say on that one? 125. I'm running out of space in micrograms per litre. Okay, which is 75 increase. Okay, and at 60 minutes, sorry, at, I said 175 micrograms per litre, which is 125 micrograms increase, which falls within range. within healthy range. Healthy range. Okay, so you can either put this conclusion at the end, or you can put that conclusion at the beginning. So you can either say patient 2 is healthy because starts at 50, at 30 minutes 125, which is 75 increase, and at 60 has gone up by 125, which is in the healthy range, or you can read it through and then say therefore they're healthy. Okay, says use data to justify, so really there's no option. I think that's not actually a bad question, not that part of it anyway, and that's that one.